For over 4 billion years, Earth slowly engineered a stable, complex life support system. Atmospheric gases and global temperatures settled into a precise rhythm, allowing deep, diverse ecosystems to thrive. Today, that equilibrium is fracturing. We are seeing a rapid drain on the precise resources that sustain life, turning previously fertile regions to dust. For decades, we treated environmental breakdown as a problem for the distant future. The math on those early models turned out to be far too conservative. The timeline has collapsed, and the breakdown is active right now. Passively observing the damage is no longer an option. To understand how to survive this shift, we have to look past the isolated symptoms and dissect the mechanical chain reaction driving our planet's failing systems. As global temperatures rise, our oceans act as a massive planetary heat sink, absorbing excess thermal energy directly from the air. But this capacity is not infinite. This constant absorption pushes oceanic temperatures past stable thresholds, building up a staggering thermal load. The consequence of deep ocean heat is violent. It attacks the submerged bases of ancient ice structures, causing massive glaciers to collapse into the sea. Every cubic meter of melting ice adds direct volume to the ocean. Compounding that math, warmer water physically expands. Together, these two mechanisms drive a steady, relentless climb in global sea levels. The ocean ice mechanism is rewriting human geography. It forces saltwater up through drains and over seawalls, bringing frequent street flooding to coastal communities. Warmer air acts like an atmospheric sponge. As the air mass heats up, it physically expands, altering global water distribution by absorbing vastly more water vapor from the ground layer. This expanded capacity means the supercharged atmosphere aggressively vacuums moisture straight out of the soil. Landscapes dry out in record time, triggering rapid onset droughts. A hyper-arid landscape is highly volatile. The dry soil and dead vegetation become perfect kindling, driving a massive increase in catastrophic wildfires. But the atmospheric sponge eventually reaches its expanded physical limit. When that supersaturated air mass finally cools and releases, it drops concentrated volumes of rainfall that outpace any historical record. These extremes are tied to the exact same engine. A warmer atmosphere guarantees that devastating floods are now the structural baseline of our climate. While the physical landscape fractures, a biological crisis follows right behind it. Evolutionary adaptation requires millennia, but this environmental shift is happening in mere decades, completely outpacing life's ability to adjust. We see this failure at the microscopic level in our oceans. Prolonged thermal stress forces corals to expel the energy-producing algae they rely on. This coral bleaching process starves the organism and destroys the foundational habitat of marine ecosystems. At the macro level, the rapid disappearance of polar sea ice eliminates required hunting grounds, pushing entire apex predator species to the physical brink. These species act as critical load-bearing pillars for their environments. Their current struggle signals a broader ecological collapse that will accelerate if the physical cascade is left running. The systemic damage is severe. However, because this breakdown is a mechanical chain reaction driven by specific industrial inputs, we have the capacity to mechanically interrupt the cycle. The root input driving the entire atmospheric engine is industrial fossil fuel emissions. To halt the cascade, this specific variable must be systematically eliminated from the global economy. Transitioning our grid to clean energy breaks our dependency on combustion. Wind power generates industrial-scale electricity without producing the atmospheric heat that fuels extreme weather. By compounding wind infrastructure with massive solar arrays and by practicing rigorous conservation, we can cut off the heat source at its origin, allowing the global temperature baseline to stabilize. The Earth's balance is currently broken, but we understand exactly how the machinery of our climate works. That knowledge gives humanity the power and the clear choice to rebuild the balance.